Hello there. Today we'll be doing number 65, implement a tray. We've done this before, but let's do it again. It's good practice, and it's a way to relearn, unlearn, and just get better at this particular algo. So in this particular algo, we're creating a way to traverse through an a tree of like alphabets, so that we don't we use less space. So one way to do this problem is to use a set of prefixes and like the word itself, but then that would be the number of characters in the what do you call this, in the word will be stored as a part of the set. And that means that we can't, we'll be using, we might have, actually, what is a set? So are we reusing the same item? I mean, yes and no. But yeah, we're reusing the same items over and over again, right? And so if we're going to try to create a trie so that we can use the nodes again and again the second time, like the same A for like 10 different characters rather than one A. So what I mean by that is, if we have one A and it spreads out to many different words, and that's like that and that, and so many words, and unlike just having an A and then AB and then AC and then AD all in the preset. We just store A, B, and C and D, and this is in the next this is in the next part of the tree. So what that means is we need a class called trie node, and we need to create the function. And we need self.children. So our children is equal to default dictionary. We can do it without default dictionary, but it's a little bit harder. Node. So node, we're going to use a key. Our key is going to be the character, and that's going to point at a trie node. So that's going to point at a trie node that has all children as well. And so those children are keys, and they have multiple keys, and we can do more things and look for more items as we traverse through the tree. We also want to know if the item has ended or not. That means if we get to a point, we want to know if this is a word that has been stored or just a prefix, as you can see in this function here. So we need the end to be equal to false right now. So to set the root, we're going to set it at a random tree node as our first trie node. That's our first trie node. Once that is done, we can move on and start inserting items into our tree. So this insertion process is pretty simple. We just need to set a cur equals self.root, because we'll be traversing through the item and we don't want to reset our root. So if for C in word, and so basically what happens is cur equals cur.children at C. So what that does is that that basically creates a brand new node for us because of default dict, and our key, and this is our value, trie node, and that means we'll create and set cur to be that particular child, and once we're done, we can set cur.end equals to true. And with that, yeah, we can move on to search. So searching is the same. We also don't want to mess with our root node. That's very important. and we're searching for this particular word. So for C in word. So if if word not in cur.children, so it is not found in these children, then return false. If it is found, let's continue searching the next character. So cur equals cur.children at C. Alright, with that, we can return once we hit the end, if we make it through an entire word, cur.end, because if it ends prematurely, if we've never seen it as an ending word, then we'll just return it as a prefix and it will not be found. Otherwise, it's the same code. Let's just copy and paste and return true, because it doesn't matter whether it is or not. I wonder if there's a way to simplify this code. Let's just run it first to make sure that it's working. Oh, what happened here? Oh, it's prefix. Right. Let's keep running. Cur.children. Oh, that's what happens when you copy code. Okay, so we have an issue here. I'm not sure how to fix this issue at this point, because I don't think we've made any errors here. So cur equals cur.children C. Yeah. I am not sure where this could have gone wrong. Aha, found it. It's this part right here. We're looking for the entire word in the children. Of course, that's not possible. Alright, so that solves this particular problem. And a fun typo there. So we have all the code in one little line. And that's how you solve it. Let's see if we can make some amendments, and let's try to see if we can learn this better and unlearn some of the things that we don't need and maybe optimize. So let's see. We set the cur, we look at the word, and we check if this character is in that, return false. If not, then move. So it looks like we reuse this part of the code, so we can make a helper function. But that's not really helpful. And I want to return the cur for this one. So let's try to do it. I mean, just for funs. So we're gonna say traversal, and self, and we're gonna look at a node, and we're gonna look at a word. So we're gonna return the node afterwards. So basically, we have a node. We're gonna pass it in, and for C in word, for every character in the word, if C not in node, well, let's just call this current, not children, return false. I thought we were going to return the trie node. What if we return the string? That's not helpful either. Okay. Return false. And cur equals cur children at C. And return cur. Can we do that? I'm not sure. And then we can do if cur. So let's try it. It's just trying weird things, seeing what happens. I mean, yeah, who knows? And also, I mean, the worst comes to worst, we can also always return a, what do you call those things? A tuple. So let's give it a shot, see what happens. Self traversal of the current item and the word and the prefix here. Set that to traverse. Can we return cur? Or can we return the whole thing? I don't know. I bet there's gonna be an error. Huh? It ran? I don't think this is gonna work. Oh, it ran? That's interesting. I bet it doesn't work here. I mean, aha. It's gonna return a bull instead of a cur. You see? I see. So this returns a bull no matter what. I see. That is so weird. Okay. Funny code, funny business. Okay, so I think we have to return a tuple. Found is found. And we do we do this as well here. Is found, traverse, word. Let's give it a shot, and let's say 0 dot end. I don't know if this makes it harder or easier to read. Looks like it's not working. Okay, enough dilly-dallying around. I don't think there was much improvement here. We tried to mess around with the code and see if we can do something funny here and try to get it to work. But it looks like we just didn't learn very much with that. But we learned that we always got to give it a shot and learn something and see if we can get something new to work. And try something and see if it works and learn something from it. See what happens, right? Just see what happens. And we found out that this is as probably clean as it gets based on the logic we need to do. And yeah, let's keep at it. And we relearned how to do a try node using children as the keys and creating more try nodes and using default dictionaries to create try nodes straight up by even creating a place to go to, which is pretty amazing. Yeah, so I hope you learned something today. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much. I'll see you in the next one.